Okay, guys, let's get started. Welcome, everyone. Please take a seat, grab a bite if you want. We are going to have 2 talks now, and you'll have plenty of time for networking afterwards, so don't worry. So it's a great pleasure to have you all. Thank you for joining this event. This is Damir and Sébastien. We are from Massa Labs and Massa Foundation, and we have a few other people in the room, so don't hesitate to come to us afterwards anytime. So today we are going to tell you more about the Massa Layer 1 and how it's important for your freedom. But this free speech is only possible thanks to BlueYard and Jonah in particular. So thank you for hosting us.
A remote control you want?
No, I have it, but it's not controlling remote. Oh, yes. It's okay. So if you allow me, I'll go back to the genesis of, can I see the slides here? Of how it all started. So we are in 28. It's one of the biggest economic crises. After a few years of wrong management, bad regulations, we have one of the biggest loss in jobs in the US since the oil crisis, and many people have to pay for their failures, of course. And this all started with a few banks going bankrupt and collapsing. Around that time, a few people thought, or many maybe, okay, this is enough. We just cannot trust banks or governments on managing money. And we know Satoshi was aware of these events and critical of these events because they cited this article, Chancellor on brink of second bailout for banks, in the Genesis block. They could have cited anything else. They chose this one to show also that no blocks were created before the launch of Bitcoin. Fast forward now, I can send money anywhere in the world in minutes with practically no fees. I can also continue to pay salaries, even if my bank goes down, unlike clients of Silicon Valley Bank who didn't have crypto. So you see, crypto can protect you against banks going down, and it can also protect you against states going bankrupt. In recent years, we have the money in Nigeria that did minus 80%, same in Lebanon, minus 90% in Argentina. So you see, crypto is also much safer to hold value there. But really, why is centralization the root of the problem here? Because when you have a small group that controls a good or service, it's way too easy to attack, to lobby, to bribe, to censor, or even to stop from the outside. And from the inside, they can impose high fees, a political agenda you don't like, business constraints you don't like, or they can even lower quality or rug pull. It's what we call a single point of failure. Decentralization, instead, can bring resilience to a network when a part of the network comes down. So all of this was about money, but there are many other things, goods, services, that are in danger of centralization right now. Basically, anything that's happening on the internet now, like free speech, free interactions between people, free access to information, they are all in danger. Social networks, for instance, they can kill your business from one day to the other, like the TikTok ban. We still don't know what's going to happen in the end. Or Telegram, they are banning many apps that use blockchain they don't like. So websites get censored. We have also examples with Sci-Hub, one of the most useful websites for scientists. It's getting hard to access in many places. We have messaging apps that, when they have no backdoors, they get attacked by governments. But also, websites get hacked a lot, in particular in Web3. There is the usual compromise key that has access to all the funds on the smart contract, for instance. But there is a quite new type of hack that is getting more popular. That is the front-end hacks. These are front-end hacks only in Web3, and they don't all fit my slides. So usually the front-end or the DNS itself get hacked, and when you connect, all your funds get drained, basically. So this front-end and DNS, these parts are central points to access these apps that are called decentralized. So, okay, let's take a breath. It's going to be fine. We have one solution to all of these dangers, and it's called Massa. So Massa is a suite of censorship-resistant, hack-resistant internet protocols and services. They're able to host all internet freedom applications or even fuel other ecosystems, and that are free from value extracting single point of failure intermediaries. It's a bit long, but I wanted to make all these points. So with Massa, you can build internet freedom, build apps that will live forever. You can build free DeFi, free gaming, communications, governance, data sharing protocols, free independent journalism, social networks, etc. You can also host Web2 stuff, but for cheaper or just safer. And you can also empower other blockchain ecosystems. So why can Massa do this? Because it's the most decentralized layer 1. Thanks to a protocol with, so we can do high transaction per second, and all of this in a pretty large decentralized network, thanks to parallel blocks. Because we have decentralized web, so on-chain front-ends and on-chain DNS, and because we have autonomous smart contracts, they can trigger operations without centralized triggers. So Damir will tell you more about these two things later. But I want to show you a few examples of what is live on Massa and that is using all of these features. So the DUSA exchange, it's a decentralized exchange that is fully hosted on Massa. So the front end is on Massa, it's safe. And they are using these autonomous smart contracts to build DCA strategies or limit orders that all run inside the protocol natively. You can do that without the need for centralized Gelato or other third-party automation. Chameleon is an NFT marketplace where you can have autonomous NFTs, like, I don't know, CryptoKitties that would evolve or breed on their own. You can imagine many things on this topic. And Adamant Messenger, it's a decentralized messenger that is censored in their country, so they're using Massa just for hosting the front end in a censorship-resistant way. So now, what's the future of Massa? It's to bring this freedom to the internet and resilience to these Web2 and Web3 apps. That's on a broader level. To bring decentralized automation to other blockchains. And also, we will study EVM compatibility at some point to bring EVM to Massa. So that was a general introduction. Now, Damir will present you a bit about DeWeb and autonomous smart contracts.
Yes, thank you, Sébastien. Can everybody hear me? I don't know if the mic's on. No, I think that's not necessary. All good? Can you hear me? Yes. Okay. So, hello everyone. Thank you, Sébastien. I am Damir. I am the CEO currently of Massa Labs. So we are divided into groups, Massa Foundation and Massa Labs. So I'm responsible for development and technology. So I'm gonna get a bit into more details on how these things work, how we achieve this freedom of expression on Massa. And first, I'm gonna talk about how we manage to store websites directly on the blockchain. So this is your usual centralized way of approaching what people call DApps. Unfortunately, most DApps are centralized because their domain name is centralized, it's hosted, it's handled by centralized servers, it can be taken down by governments, it can be taken down by people paying money, it can be hacked, it happened. The website themselves, they are the entry point. I mean, the website is the entry point all the users use to see your website, to see your DApp, to interact with it. So if this is compromised, you're screwed. So here, unfortunately, on most cases, DApps have front ends that are stored on AWS or stuff like that. They get hacked. We saw it recently. There was some catastrophe with Bybit as well. So anyway, we see that we have a huge problem with this because the biggest part of a DApp is actually centralized. The DNS, the server, and only the smart contract is actually the decentralized part in DApps. The idea here is that we want to fully decentralize all these things: the domain name, the website, and the smart contracts. So the smart contracts, we'll look at it later. They are already kind of decentralized on blockchains, but there are central points of failure still in them that we're going to remove. But first, let's look at the DNS and the website. The idea here is that the same way traditional blockchains store smart contracts, we want to store full websites, full front ends. So these front ends are fully replicated over thousands of nodes around the world. So you see the schematic here of the nodes we have currently. These are nodes run by people at their homes typically, or on small VPSs. It's highly decentralized. It's many countries in the world. It's very hard to take down. And your website is fully replicated all over there. So now it means that you could deploy on Massa a full infrastructure, so your website, the domain name, and your smart contract, and you would not require to run any infrastructure by yourself in any centralized service. So let's build this step by step. Let's first have a look at the Massa name system. So this is the naming system to buy a domain name. So mywebsite.massa, that's where you would get it. So here's a little screenshot of our Explorer. That's my address and all the domain names I own. So that's my personal one. And some of you might have heard of ENS, the Ethereum name system, which is kind of our competitor on the Ethereum side. But the difference is that in our case, Massa domains do not expire. There's no governance over them. It's fully decentralized. Its code is law. There's no DAO or something that handles them. The registration fee is locked on-chain, so there's a registration fee. It's locked. We don't profit from it. There's no recurring costs, so you pay once and you have your domain name forever. You don't need to pay on a regular basis. For us, this is a cause of centralization in other systems. Here, the idea is that you pay once and you hold forever. Resolution itself, so to resolve a domain name, it's free. And if you free your domain name, if you delete it, you get 50% of the fee refunded, and the rest is burnt. It's not given to us or something, it's burnt. So this motivates people to free domain names as well. It's also compatible for smart contracts to interact with them programmatically. So smart contracts in Massa are special. I'll show you later. And the idea is that we allow them to interact programmatically with this. And finally, domains in Massa can be made immutable. This means that you register a domain name and then you lose the property over it. And even you, if you wanted, you could not delete it anymore or change it anymore. So that's something you can activate optionally in your system. And I'm going to show you just quickly what this looks like. So this is the domain name manager for my address. It's a Massa Labs technical address. And you see, we have some own domain names. I can change the target to which it points. I can change the ownership, so basically who's the owner, who controls this domain name. And I can choose to lose ownership there, or I can free the domain name. Then I will get back 50% of the coins. Or I can choose to register a new domain name. So for example, my domain. Okay, no, sorry, this is already taken by someone, but I can register my domain for, and it's going to estimate the price it's going to cost me. Of course, a shorter domain name is going to cost more than a long domain name. And the idea is that once I have, not sure why the Wi-Fi is struggling here, but the idea is that once I register, the domain name is mine, and it's mine forever until I free it. So that's kind of the idea. So let's get back to here. Now that we have this first ingredient, which is the domain name, the next step is the website. So how do you upload a website on-chain? We have two tools, one command line tool for developers, and also an upload website that allows you to just click, upload your zip file, and it's there. It's on the blockchain. Here again, the payment only is used as a way to avoid any kind of flood. You pay in coins once, the coins are locked, and when there's no recurring payments, you don't need to pay over time, you pay once. And if you free the data, you get the coins that were locked for the space back entirely. So this is quite interesting because the website here is stored the same way smart contracts are stored. It's completely uncensorable, it's replicated over all the nodes, and you have it working. So next question would be, how do you access these websites? There are two ways, let's say. If you're in a country where you can just freely open any website almost, then you can use third-party providers. So people in the network who decided to provide access to others to these websites. Or if you're in a country, for example, that restricts access to the providers, you can install a local software that allows you to use your local server to connect to the blockchain and from there retrieve the websites. I'm going to show you how it works, actually. So here I have launched a local server. And the idea is that, for example, I want to access the list of decentralized websites. I have it here. As you can see, I don't know if you see it very well here, but it's on my local host. So here I'm accessing through my local computer. Nobody can censor me. And this website that I open here is actually a website that is itself hosted on the Massa decentralized web and lists all the websites that are currently there. So, for example, Sébastien told you about Adamant. I can decide to view it. It's going to ask me something that's a bit unusual, how I want to visit this website. I have the choice between the local host, so that's if you have the local software installed, that's the most safe way to do it. But maybe I want to go through a provider because I don't have anything installed or I'm too lazy to install something. I can just go through any of the existing providers. I click View, and it's going to open Adamant Messenger. And this is exactly the way Adamant Messenger are using Massa currently to escape censorship, especially in Russia and China, where they were blocked. Now they're using us to be available and finally be able to reach these people. And of course, to upload the website, it's pretty easy. You click here, you just drop your zip file and you upload. I cannot show it here a bit because the Wi-Fi is a bit unstable, but that's the general idea. So feel free to try it yourselves. I'll show you all the links afterwards. Everything is working. You can play with it. Here you have the link for the documentation. I will send you afterwards. Don't worry. And that's exactly how we built a decentralized web, a way for people to host their websites, fully decentralized, fully replicated. We have tricked a bit the way blockchains work, because usually blockchains have that, but for ledgers and smart contracts. We have changed it for a non-financial application, which is literally storing websites the same way smart contracts are stored. Fully decentralized, replicated, available everywhere, and nobody can censor them. So that's the first step. And now I'm going to enter into a second part that's quite unique to Massa, because we have detected that this was not enough. There is another blocker for full decentralization. And to understand where that blocker lies, you need to understand how people usually perceive applications. So here's a typical example of an app. It's centralized. It's on a server. It's called App1. And let's say it's a game. So a user that has some kind of authentication or key or password calls the server, and the app executes whatever the user asked. Typically, player actions in finance, order emission on a centralized exchange, for example. Resource requests, any kind of on-demand tasks are handled like this. But people, most of the time, forget that this is not the only thing apps do. They don't just wait for users to do something in order to perform an action. A lot of times, you need, for example, in games, you want NPCs to move even if the user is not there. You want, in finance, orders to expire even if the user has not opened their computer. You want some kind of automatic refreshing of some data. You want to defer some tasks or have some periodically executed tasks. And unfortunately, blockchains are blockchains are not made for that currently. This is how a blockchain works. A user that has a secret key that gives them access signs a transaction. It's sent to the blockchain where basically block producers are going to include the transaction to be executed, and the transaction will be able to call a smart contract that represents the D app. And then the smart contract can call another one, but that's all in a single call. So what happens if we have use cases where we need to update some idle game states, run some autonomous AI, make NFTs evolve over time, even if the user is not there, send funds to someone at regular intervals, do some trading bots. All this is currently impossible without requiring some kind of user, to sign and send the transactions. And what people do usually is that they run a server, which is here, that has a secret key hard written in it, and this server wakes up on a regular basis and sends a transaction to the blockchain to maintain this smart contract and this app for all the tasks where they don't have to wait for the user to be there. And this is a huge market because people don't want to run this server by themselves. They defer this to other entities, just like you would defer website hosting to AWS the same way. People focus on using two main things that are Chainlink automation and Gelato Web3 functions. These are the biggest players in the game. You would give them your private keys. You would tell them which functions to call at which interval, and they will do it for you. You will trust them with this, and that's how it works. That's literally how most of DeFi currently, almost all of DeFi works. They will not tell you that because that's behind the scenes. It's not user-facing, but they all use this. And sometimes it fails. For example, here, you see that there was this critical poke transaction, so to poke the smart contract on a regular basis. That was delayed because the blockchain was congested. And you see there was a financial loss of 4.5 million by MakerDAO in 2020. So this is from a scientific article, actually. So you see, this solution is not ideal because it causes centralization. You trust these entities. It can cause service interruptions if they're down. There's a risk of being hacked because, remember, they have your secret key. It incurs very high costs. It's actually quite expensive. And it has unpredictable delays because, remember, these servers, they send transactions, and if the network is congested somehow, it can take time, or maybe the transaction might not even be executed at all because the fees is too small or something. So to summarize, here is the current state of DApps in Web3. The domain name is centralized, the website is centralized, and the keeper bot that automates smart contracts is centralized. Only the smart contracts are decentralized. So what we did is this. Remember, we did the DNS on-chain, the website on-chain, and now we added another thing which is unique to Massa. It's a system that allows smart contracts to register future calls, to wake up on regular intervals, to do stuff like this that would normally require external triggers to call them. So just to give you an idea, hopefully, yeah, preloaded it, good thing. We have built some apps, for example, this one, where you can literally send money on a regular basis to someone. You register the call, and you give the address, you give the amount, you give the intervals, and you schedule it, and it's going to be executed every minute, every hour, or whatever. And the person is going to receive the money right away. They're not going to have to claim it or something weird. They're going to receive it. So feel free to try it. It's on sintra.massa.network. Feel free to play with it. And so this is just an example, but we can do much more than this. We can automate a lot of stuff. And the one thing that we miss here is that, as you can see, we are still an isolated system. It's still just Massa, automating Massa. So it's Massa smart contracts, automating Massa smart contracts, and living forever there. That's cool, but it's even better if we manage to automate other blockchains using our system. And the cool thing is that we have a very nice partnership with Kima Finance. And these guys, what they do is decentralized cross-chain messaging. So what we have done is this. We have Massa there. It's autonomous. The smart contracts can evolve by themselves over time. They don't need any external triggers. And they can decide whenever they want to call functions or send data or value to any other blockchain. So this happens through the Kima network. And it's highly decentralized. So here's a little example where we have built a smart contract on Arbitrum. And I'm going to show you if it opens. Wi-Fi is terrible, sorry guys. It was better when there were less people. OK, here you go. So this is French time, sorry for this. But the idea is the following. What you see here is a smart contract that is hosted on Arbitrum. It's an Arbitrum smart contract. It only stores a timestamp, a point in time. It stores it in its own storage. On Massa, there is another smart contract that is autonomous, that wakes up every 20 seconds. And whenever it wakes up, it sends a timestamp, the current timestamp, to the Kima network, which relays it to the Arbitrum smart contracts. And every 20 seconds, the smart contract on Arbitrum is going to update thanks to this system. What you're seeing here is this running live. And actually, if you look at the top here, the website itself is hosted on-chain. So what you see here is the very first fully autonomous Arbitrum D app. The domain name is on-chain. The backend is on-chain. The front end is on-chain. Automation happens fully on-chain. There's not a single external player that's centralized. Message passing is through Kima, through many nodes. So everything is unstoppable here. It's going to run forever. So that's kind of what we did. And yeah, so if you summarize everything here, we have managed to put front-end, back-end automation, back-end, domain names, everything on-chain. And if you look at it from the global perspective, it means that somebody can just come to Massa, deploy a full project, a full D app, and then that person can literally disappear. It's going to run forever. They don't need to be there. It runs without them. And this is currently something that does not exist. Currently, when the team stops or quits, the project dies. Here, there's no single point of failure. It runs fully autonomously, fully on-chain. And for us, this is what unlocks true freedom of speech. So yeah. Thank you. If you have any questions, feel free, yeah?
What is the incentivization structure for running a node? Like, how do you incentivize people to run a node when, like, the payment is only once?
OK, here's where it becomes interesting. So it's a blockchain. It has a token, the Massa token. And this token has an inflation. So whenever a block is produced, some tokens are created and given to the block producer. They also get the fees from the transactions they include. So they're paid like this, the node runners. We have actually thousands of them, and it's actually highly profitable. I think you get like 30% APY currently. So if you 27, OK, it dropped a bit, but 37, OK, it went up. Sorry, just if you want to run the node, actually it's highly it's highly convenient because we made sure that it's very easy to run a node, very cheap. On a normal laptop, you can run a full node on Massa. You don't need to run a night node or something. You have the full node on a laptop, and it runs. You just need a hard drive of 1 terabyte, that's all. And this is enough. You can run a node. All of you here can just launch nodes tonight. It's going to be running, and there's no blocker. It's very easy. In terms of coins, you only need 100 coins to start running a node. It's very cheap. And you participate meaningfully. So it means that the rewards are very frequent. They're small, but very frequent. So it removes any incentive to pool. And what's the economic system of the decentralized web and all of this? Well, every transaction you send has a small fee, 0.01 Massa. So that's one thing. And the second thing is that, remember, when you store data on the blockchain, you lock coins. And when you free the data, you get your coins back. But as long as the coins are locked, it actually reduces the circulating supply, which boosts token up. So that's the incentive measure. Basically, we reward people through deflation caused by usage.
You will also soon be able to vote on the blockchain. Like we will soon have on-chain governance. As a start, you will be able to vote for blockchain parameters, like you don't like the token reward, you don't like the time between blocks, you can propose something else. This and the grant system, you will be able to propose a grant project or a vote, give approval or not to some grant projects.
Is your blockchain permissionless? And if so, do you run any regulatory risk of someone coming and hosting something illegal?
Good question. It's fully permissionless. We could disappear tomorrow, it will still run. So the idea is we technically do not control anything here. It's a bit like people who created Tor. Now Tor, even if they wanted to stop it, they could not. We have a similar situation. Of course, I'm not a legal expert. That's why we have paid a lot of money for proper legal expert in Switzerland and France. And we might, actually soon we're going to add a bit of, how it's called, disclaimers here and there. But once you validate them, technically, you accept the risk that you might see something you don't like there.
On centralized web, you have like TLS or HTTPS to make sure that the communications aren't tampered with when the server reply. So I'm curious, do you have something like that from Massa network to the client if it goes through like a third party?
So if we get back to how it's built, let me find it quickly. Here. So if you are in the case number 2 here at the bottom, technically in the ideal case, you run your own node and you run your own provider locally. So you're just reading the blockchain. It's as secure as reading the blockchain. Technically, you have a full copy on your computer of all the websites. So if you want to become a third-party provider, you set up the server locally, and you can serve in HTTPS. But you're right, people have to somehow trust the fact that you will not alter what you have read from the blockchain. That's why it's much better to actually run directly your own local provider. That's what's recommended. That being said, we are currently working on something that would allow you in the future, not ready yet, to have a plugin in your browser that checks the signatures of what you actually receive. And this would not prevent censorship, because if the provider refuses to serve you something, it would still refuse it. But at least if they send something wrong, you'll see it. And the other option still exists. Run your own thing, and you have access to everything. Nobody can block you.
I guess what I'm worried about is that, say, a third-party provider got compromised and they serve you like a malicious PX.
Yeah, so that's currently a risk if you go through a third-party provider. A bit of the same risk you incur when you use an RPC, right? To read data from the blockchain. You trust the RPC blindly, right? Exactly. So that's tricky. I would recommend that you use the bottom solution for now. And one day when we have the capability to verify signatures in the front end of your browser, this would be acceptable, but I would still not play with it, because censorship is possible by these guys. That being said, there's many providers. We have about 10 providers currently, and you're all welcome to register as a new provider. You can all become a provider. You install all the software on your computer. You need to have a domain name, and it's gonna be you're gonna be registered, and anybody can use you to access the system. So if you don't like one provider, you can use another one that you trust more, or the best way is you don't use a provider. They can be censored, right? So you can just skip that part.
Maybe someday we'll be able to run the node on your phone to have direct access.
And actually, this guy there managed to run the node on his phone. Yeah.
Also have the DeWeb provider. In Stornoway, if you're interested, there is a website on the DeWeb too. Just look for droid.whatever provider you have. You'll find the instructions to install.
Yeah. Any questions? Yeah, go for it.
How do you so when you have this structure of paying where you pay once and then it stays there forever, like it's going to be there for a long time, how do you make sure that data integrity data is kept intact over time?
Yeah. So when you upload the smart contract on Ethereum, how do you know it's going to stay there forever? It's exactly the same mechanism. The idea is it's replicated on all nodes, and we have this thing where if a node does not provide the right state hash or does not follow the right state hash, it's rejected and banned by all the other nodes. So if a node changes just one byte in their own state, they will diverge from all the other nodes. They will be rejected. They will actually create a fork, a hard fork. So that's what would happen in this particular case. So how do we ensure it's going to stay forever? Well, the same way Ethereum ensures smart contracts are there forever, because there is this incentive as a node runner to not lose money by diverging from the rest of the network.
It's way more safe than decentralized storage that you have in Filecoin, for instance.
Yeah.
When it can still disappear.
Yeah, I'm just when you run this in consumer grade hardware, you don't have the same guarantees hardware-wise that your data is not gonna rot.
Yeah, that's
so
very true.
How do you make sure that when you have a network of consumer grade hardware servers?
Redundancy.
Okay.
The likelihood, imagine the likelihood is 50% that one computer fails over a year. But what's the likelihood of all of them failing at the same time? Almost zero, right? Over thousands of them. So that's how we do it. It's fully replicated on all nodes, and as soon as one of them diverges, it's ejected by the others.
So, yeah, but I as a user don't have really an influence when my computer starts running bad, right?
Yeah, that's fine.
So then I get slashed and I can't participate in that.
You don't get slashed. You diverge, you get banned, your IP address gets banned temporarily by all the other nodes, so you cannot connect. Your node is isolated from there on, temporarily, until you fix your problem. You fix your problem, you rebootstrap from the other nodes, you recover the blockchain, and once you have everything back together, you can rejoin the network after 1 day of ban.
So the software that you run on your device doesn't have inbuilt erasure encoding or something like that?
No, not necessary, because we have full replication. Yes?
Just playing devil's advocate here.
Go for it.
One client?
I mean, in terms of clients, that's the thing. We have provided a platform. Does Tor have clients? You know, that's kind of the thing. Well, for the clients part, we have shown a couple, like there's Adamant. I mean, I can show you the list of websites. That's very new. We actually published this earlier this year. So we have Adamant, who uses actually us for that. But is it a client? They're not paying us, right? It's not really a client. They just use storage space, which locked tokens, which decreased the supply, which increased the value of our tokens.
All right, sorry. I mean the client to run the chain, you know.
Oh, well, node runners, we have 1,200 approximately around the world currently. It's people running nodes, and it's very cheap.
I think you mean the code, like the source code.
Running the same software.
Yeah.
They don't have different
Not yet.
implementations.
Not yet, yeah.
That could be a grant if you want.
If you're ready to code one, we can pay you.
Multiple clients.
Sorry, when I heard client, I heard like actual clients. Yeah, okay. That being said, for the automation part, we want soon to wrap this as an actual product that would look and feel exactly like Gelato, do exactly the same stuff, but be cheaper and more decentralized. So that could become a product with clients.
Do you have any inbuilt privacy features?
Currently, no. The blockchain is open and public. That being said, if you run your own node, nobody knows what we visited. Nobody knows what you did. Nobody has a clue. So you're free also to use the storage space of the blockchain by encrypting stuff before you send it there and decrypt it back when you retrieve it. That's fine. But the blockchain itself is public. Yeah. That being said, we have pretty big contracts with Starknet and Polygon right now. We are working on ZKs, and the idea would be to see if there's any way we could add a native privacy layer there, but we're not there yet. All good?
Let's network then.
Yeah, guys.